Hello everyone again. This is the another problem, and then we have a jet belt with a man of 200 lb weight, and then engines provide the thrust in x direction, which is 35 lb, and then in y direction 300 lb. Then determine the total distance the man travels 5 seconds after takeoff. What is his velocity at this instant? And then, as always, we will start writing the force balance. And then let's write the forces. So we have the weight of the body, and then we don't have a normal force. That's very important here because it's not the body is not resting on the ground. So no n. So okay, and then we have the force in x direction, and then no force in this direction as a resistance because air resistance is not considered. And then with this in mind, let's start. So first thing is first, that acceleration will be in the forces acting in x direction, and in x direction let me put the, so I will say that this is y, and then this is, let's put it okay, this is x. So then it will be that 35, which is in negative x direction, that will be equal to the mass, which is 200 lb. So let's put mass as, okay, let's firstly put it this way, and then mass will be equal to weight by the gravitational constant. Weight is 200 lb by the gravitational acceleration is 32.2, and then that will be equal to 6.52 pounds. Okay, and then this one we will replace back to here, and then find the acceleration. Okay, so let's do that. Then we have the, so we have, okay, so 35 by 6.52, it makes 5.37. So AX is negative 5.37 feet per second squared. Okay, so negative value means that the acceleration, negative means the acceleration is in negative x direction. So what it means is that, as expected, because it's not so hard to, if you have a force in that direction, then it will accelerate in that direction. Okay, so then comes for the forces in y direction. So it will be that ma into y, and then we have the weight of the body, which is 200 lb. Let me write the forces first. Then Fg, which is negative, downwards, or weight. Let me just, and then plus the Fy, and then that will be equal to May. And Fg is negative 210 plus Fy is 300, and then M is 6.52 times the Ay. From here it follows that 90 by 6.52 is 13.8 feet per second squared. Okay, then the question comes, what is the velocity at 5 seconds? So at time is 5 seconds, it asks for the velocity. Okay, then the procedure is very similar to this one. I will just integrate this velocity with respect to time. Okay, I will not write this equation one and again, but this is a very simple equation that you will almost use it. So I will say that dv in x direction from 0 to vx will be equal to then 0 to t ax dt. Okay, that's the equation. Okay, so time is 0, the velocity is 0, and time is t, velocity is v. So this is exactly the same equation I will have, and that will be equal to va is equal to ax into t. That's the equation. And then similarly I will have the vy, and then, so let me just put it as well. So you will just put that 0 to vy, and then we will have the dvy is equal to 0 to t ay dt. Okay, and then since ay is constant and this one is constant, therefore you can write it here. Similarly, this one is constant. Okay, you can put it here, and then it comes out that then vy is equal to ay t. Then if you replace these ones, and then ax is in negative x direction, okay, that's expected, and therefore I will just have the ax into time, and then vy will be ay into time. Okay, now coming the position, exactly the same equations we will have it here from 0 to s and from 0 to t, and then 0 to s, I will just put it as dsx to make it clear, and then it will be that vx and then dt 0 to t, and then it will be that sx will be equal to, when time is 0, that sx is also 0. This is very important. Yes, time is 0, the position is also 0. Okay. And then that will be equal to, if I replace vx 0 to t ax t dt, that will be ax t squared by 2. Similarly for y, it will be that 0 to s, let's put it sx, and then sy, then dsy, that will be equal to 0 to t vy dt. Okay, and then from here it follows that sy exactly that will be the same ay t squared by 2. As I said, if you want, you can use the derived equations from the book. Okay, no need to derive again. No need to derive again. That's very important. So we have the sx, we have sy, we have vx, and then we have vy. Then time to replace it and then find it. So then from here it follows that then vx will be equal to, ax is negative 5.37 times 5. So negative 5.37 times 5, that will be equal to 5.37 times 5, 26.85 feet per second. That will be of course negative. And then vy will be equal to, then ay is 13.8 times 5, and that will be equal to 13.8 times 5, 69 feet per second. And then similarly sx will be equal to negative 5.37 times the 25 by 2. Okay, and then that will be 5.37 times 25 by 2, 67.12 feet. Okay, and then sy will be equal to the same, exactly 13.8 times 25 by 2. Okay, 13.8 times 25 by 2, and then 173. 2 point something, yeah, 5. Okay, these are the Sx and these are the Vx values. Then to find the final distance, so what we will do is that the S will be equal to, like the Pythagoras theorem, Sx squared plus Sy squared. Okay, so you have the so it's like you are moving in y direction and you are moving in x direction. You are trying to find what is the distance that you have traveled in the total sense. So you can write, let me just put it this way, write it here again. So I have the Sy and I move to the left, Sx, and I can show this one as the Sy and then Sx. Okay, and then I started here. I just moved this one here. Okay, just move, no problem. And then this will be my S, and then this is 90 degrees, and that will be just the Pythagoras theorem. Okay, and then that will be the square root of 16.72, 67 point, okay, this one is also negative, sorry. Then this one is also negative, and then we have this one is squared, actually no need to write the negative value here, and then squared plus 7 plus 5 squared. Okay, and then let's find it. 67.12. Okay, that's the 400 plus, we have okay, and then the square root of this one, 185 feet. That's for S. Similarly, we will do the V, and then V will be exactly the same as Vx plus Vy, and then squared, and then squared. Okay, exactly the same procedure. Yes, we have the Vy, and then we have a Vx. I can show this one as Vy here. I can show this one as a Vx here, and then again I will have the V, and then Pythagoras theorem. So Vx is 26.85 and 69. Okay, that will be 26.85 squared and plus 69 squared. Okay, and if you calculate it, you will get 26.85 times plus 69, and then square root of it will be 74 feet per second. Okay. That is the final result. There may be a small calculation error here, but I believe there is not. Okay, thanks for watching, and then I will see you in the next recording.